Welcome to Astro Morning Tea at ICRAR. I'm Greg.
And I'm Luke.
And we're here to talk about fun science stories, probably astronomy related, maybe not. Who knows?
Who knows, Greg? We're back.
That's right, we're back and we're standing up.
I know.
Look at this.
Actual real legs.
My goodness.
You wouldn't believe that we had them.
We can't afford to put in the legs, though.
Greg, I like your boxer shorts.
That's very, well,
very nice.
Very sciencey.
Stars.
That's true.
Yeah, lovely. So, moving on to our first story this week. Greg, we're going to be talking about removing debris. Mm-hmm. This is the satellite Remove Debris, which has been launched from the
International... Good name for a thing that removes debris.
It is International Space Station. Actually, the largest satellite that's ever been released from the International Space Station, and it's out there collecting debris, isn't it?
That's fantastic. Well, there's a lot of space junk up there in space, which is a good place for space junk to be, I guess. Or not. It's like a bad place for space junk to be. But so we want to get rid of it
here.
But we want to bring it here. Because the problem is that if we have too much up there, when you fly a rocket with like SpaceX or Blue Horizon, someone goes into space tourism, and you get hit by a baseball of size metal thing, then you're dead, and that's bad for space tourism.
They're all like burgers up there and things, right? Things school kids have sent into space.
Yeah, that's right. That's another story for another time.
So yeah, this Remove Debris is a British satellite that's been launched from the International Space Station. It's going to actually try and collect some of this debris, and it's got 3 different ways of doing it. So it has a harpoon, a net, and a parachute. It's great. It's like going around collecting things like the Wild West in space.
It's so great. They should have called it Ahab. I kept thinking Remove Debris is a really boring name. They should have called it Ahab.
You should go into PR. Satellite PR.
Could you imagine, like admittedly, that you'd end up tying yourself to space debris and then riding it back to Earth?
Yeah.
Read a book.
This thing actually has it has these little CubeSats that it sends out and then it tries to recapture. So it's got one it sends out and it fires a net at it, and it's got one it hangs on an arm and then it blows up a balloon and tries to shoot it with a harpoon. It's pretty amazing. And then it has its own parachute, which is going to blow out and then slow itself down and it will burn up in the atmosphere. So the idea is to test these different methods for collecting space junk.
That's fantastic. I love it. I love that, like the old techie, modern techie kind of idea.
Yeah, it's cool.
That's great.
So also in the news this week, there was a really interesting story about proving Einstein's theories of gravitational, oh my word, general relativity. I forgot what I was saying.
No one knows
We're broken. We'll just move on. We'll move on. Basically testing it in a galaxy that's thousands of light years away. Basically, people, you may know about this stuff called gravitational lensing. Gravitational lensing is when you have a load of mass in the foreground and you have something very bright behind it. Okay. And the light from this background thing gets bent by the mass of the foreground thing.
Into the camera.
Yeah, it gets bent round, and what you see is this like nice arc of light that comes from the background object. Now, looking at the distribution...
An Einstein ring.
Oh, that's great.
Thank you very much.
You've been reading up.
I have been.
The distribution of the light in this ring actually tells you the mass of the thing in the foreground.
Wow.
Okay, and that's through Einstein's theory of general relativity, allows you to work out the mass of the foreground. What this paper have done is they've measured this, and then they've also measured the mass of the foreground galaxy by looking at the velocity of all of the stars within that galaxy. So the velocity of those stars is related to the gravitational potential, which is then related to the mass. So you measure the mass in 2 different ways. And what they found is that those 2 things give you pretty much the same answer. So what that means is that if you use the equations of general relativity, and you use the velocities of the... You're not sold. The velocities of the stars, it basically shows that Einstein's equations work well in this distant galaxy.
I'm not going to argue with the astrophysicist, but when I read the paper, it was...
You should. That's the whole point, Greg.
Okay, I will. They went, it shows that we're within 9% correct. And I was like...
That's very correct in terms of astronomy.
That's a big error bar.
No, that's good enough.
If I'm driving down the street and I was pulled up by the police for speeding, and they were like, well, I think you're speeding. I think you'll find I was within 10% of the speed limit. And they'll go...
You're on 9% of the road.
Yes.
On the road within 9%.
You're nicked, sunshine. So, yes, yay for astronomers. But it is pretty impressive.
Okay, moving swiftly on to our question of the week. So this week we have a question from Catherine, and Catherine has asked, why do stars have different colours? So this week, ICRAR PhD student Picky is going to tell us all about it.
The colour of a star has mostly to do with its temperature. If you consider a wax candle, for example, the outer part of the flame is yellow in colour and is around 500 degrees cooler than the inside part of the flame, which is blue in colour. So it works the same way for stars. Blue stars are considered way hotter than the yellow or the red stars. If you think about the electromagnetic spectrum, for example, the red part or the infrared area, that is cool, and if you move towards the blue or the violet part of the spectrum, it becomes hotter. So if you have a white dwarf, for example, they are way, way hotter as compared to the red supergiants. So the hotter the star is, the more blue it is.
Thank you, Picky, for answering that question about the colours of stars. Hope that answers it for you, Catherine.
So, on to the random fact of the week this week. So, Greg, why is America not called Columbia? Or Cambodia?
Well, I've got to say, it wasn't discovered by Christopher Columbus, so that'd be really weird to call it Columbia.
Yes.
That would be
so
odd.
Columbus did make it to the Caribbean in 1492, as the song goes, but he wasn't the first person to make it to the American mainland. That accolade goes to John Cabot, who was actually Giovanni Caboto, who was from Venice, I think. But then went to the UK and was actually funded by the English, and they gave him the name John Cabot, so he sounded more English. He was the first person to set foot on the US mainland in 1497, but America isn't named after him either. So America is named after Amerigo Vespucci. Apologize for my pronunciation if that's terrible. He didn't actually get there till 2 years later than Cabot. So why is it named after him if he wasn't the first person to get there? And he actually landed in South America as well.
I'm going to guess. Well, it's all the Americas, isn't it? It's the Americas. Yes. It's just one part's north. I'm going to guess because he wrote the book. He went, I found a thing, I'm naming it after myself, and so his name's on lots of stuff.
That is actually kind of true.
Oh, cool.
So it wasn't that he named it after himself, so he wrote lots of books about his travels. So he was the only person who publicized himself very, very well. And his books got translated into loads of languages that went all around Europe, and they were very, very popular. Then in the early 16th century, a group of German map makers were making maps of the New World, and they actually used his logs to produce these maps. And when they were making the maps, they said, oh, well, he's the guy that did all of this. He's the famous one. We'll name the continent after him on our maps. Sure. And this then took off. That was in South America. And then when some famous maps were made later on, about 20 years later, somebody looked at their maps and said, we'll just name the whole continent America. So it's not named after anyone for finding it first. It's actually named after the person who publicized it the most. So therefore, this is a lesson in life to make sure that you publicize yourself and you make sure everyone knows what you're doing, Greg, because then you might get a continent named after you.
That's
Greglandia.
Greglandia. That's look. I quite like that. That's got a ring to it. Does that mean Australia should be Hartogia?
Yes.
Good.
We'll start the campaign now.
Yay for Hartogia.
I'm going for Greglandia.
So, I didn't publicize Australia.
You could start.
I could start. Everyone, go to Australia.
Is that it?
I think I said. Astro Morning Tea is done. Sold. Brilliant. Amazing.
The wad of cash from the Australian Tourist Board will be coming in soon. I'm sure after that glowing praise of Australia. Just come.
It's here. It's not going anywhere. Actually, it's moving north at that 10 centimeters a year. So anyway.
You'll miss it. Come or you'll miss it.
It crashes into Indonesia. Thank you, Luke, for coming along and talking science today.